Okay, let's talk about our planet. Have you ever really stopped to think about what it takes to clean it up? I mean, we're not talking about just picking up litter. We're talking about the massive, complicated messes that are threatening our health, our ecosystems, everything. Well, today, we're diving deep into the world of the engineers who are right there on the front lines, tackling this incredible global challenge. So who are these people? When a factory has a chemical spill, or the air in a city gets so bad it's dangerous to breathe, or a beautiful lake gets totally choked out by algae, who do you even call? Seriously, who has that wild mix of skills to even know where to start with problems that big? And believe me, the stakes are absolutely massive. Get this, according to the World Health Organization, a jaw-dropping 99% of us, pretty much every single person on the planet, is breathing air that's considered dangerously unhealthy. This isn't some far-off problem for future generations. No, this is a right here, right now reality for all of us. The answer is the environmental engineer. These are the folks we're talking about. They're part scientist, part designer, and 100% problem solver. They take principles from biology, chemistry, and engineering and just weld them together to literally heal our planet. You could almost call them the unsung heroes of our modern world. All right, so what kinds of battles are these engineers actually fighting day in and day out? Let's break down some of the massive challenges they're facing in this crazy, complex world of ours. And what's wild is just how diverse these problems are. I mean, one day you could be dealing with contaminated soil from some old industrial spill, and the very next day, you're designing a high-tech system to give an entire city clean drinking water. They're tackling it all, from the air we breathe, to algae blooms in our rivers, to the very ground under our feet. Now, to fight problems this varied, you need more than just a good attitude, right? You need a seriously advanced toolkit. So let's get into the incredible science and tech these engineers are using to fight back. Their arsenal is just huge. It's everything from the hands-on gear they're using out in the field, for surveying and monitoring, all the way to powerful computer simulations that can model exactly how a problem is unfolding. We're talking about a mix of boots-on-the-ground investigation and some seriously high-tech analysis. Okay, one of the absolute game changers in their toolkit is something called GIS. The easiest way to think about it is like a superpowered, intelligent map. Imagine you can layer a map of a city's drinking water wells right on top of another map that shows how a chemical spill is spreading underground. Boom! Instantly, you can see exactly which wells are in danger. It turns a confusing mass of data into a crystal-clear plan of attack. And get this, they don't even need to be on the ground to collect critical information. That's where remote sensing comes in. Using tech on satellites, drones, and aircraft, they get this incredible bird's-eye view of a problem. They can monitor deforestation, track how a coastline is eroding, or see the full scale of damage from a disaster, all without ever setting foot there. It's amazing. Okay, so we've seen the problems and we've seen the tools, but how does it all come together in the real world? Let's look at an actual case study to see how these engineers take a situation from a total disaster to a real success story. Just look at this transformation. This is Lake Agawam in New York. On the left, you see a complete environmental disaster. The water is totally choked with toxic blue-green algae. And on the right, well, after the engineers did their thing, it's a perfectly clean and safe lake again. The big question is, how on earth did they pull that off? It all comes down to a really systematic process. First, you have to assess the situation. That means getting in there, taking water and soil samples, and really understanding the unique chemical fingerprint of the contamination. It's like being a detective. Once you know what you're up against, you design a custom solution like picking the perfect water treatment system for that specific problem. Then, you implement it. You actually get the equipment installed and running. And you're not done yet. The final step is to monitor everything, constantly testing to make absolutely sure the problem is solved for good. And this quote from Renata Spinoza, one of the engineers on that project, really says it all. She says, "Seeing the end result and knowing that we solved that problem is my favorite part of my job." And you can see why, right? It's that incredibly tangible result, that satisfaction of turning a disaster zone back into a thriving, healthy place. That's got to be an amazing feeling. So when you picture an environmental engineer, what do you see? Someone in a lab coat, or maybe someone out in the field wearing a hard hat? Well, the truth is, it's often both. The day-to-day life of an engineer is way more varied than you might think. If you look at a typical time split, it might be something like 60% in the office and 40% in the field. But, and this is a big but,
The slide notes that this can vary a ton, depending on your specific role and how much experience you have. The main takeaway is that you're definitely not just stuck behind a desk all day.
Let's talk about that field work. This is the boots on the ground stuff. We're talking about being on site, overseeing the construction of a new remediation system, collecting those crucial soil and water samples, or using GPS to map out a site. You're out there talking to people, getting your hands dirty. It's the detective work part of the job.
And then, back in the office, all that raw data gets transformed into a plan. This is the analytical part of the job. You're poring over the data from those samples, writing up technical reports, using design software like CAD to actually engineer the solutions, and then communicating all of it to clients and government agencies. This is where the big picture strategy really comes together.
So, is any of this sparking an interest? If you're feeling inspired, the awesome thing about this field is just how many different ways there are to make a real impact. So let's talk about what it might take to become one of these planetary problem solvers yourself. First thing to know, environmental engineering is a massive umbrella term. It covers so much, from water treatment and air quality to renewable energy and waste management. And because our world and its challenges are always changing, this field is constantly evolving right along with it. And that brings us back to this fantastic piece of advice from Renata Spinoza. She says, because the field is so broad and always changing, if you see an opportunity, you should just take it. That's so true. The key is to be curious and jump on new chances, because who knows, the problem you end up solving might be one we haven't even thought of yet. So when you really think about it, from the water we drink to the air we breathe, the work these engineers do touches every single part of our lives. It's a career filled with purpose and a chance to make a massive, positive impact, which really just leaves one question left for you to think about. What problem will you solve?